Hello everybody. Today we're going to talk about the Tormach Drawbar controller board, part number 31979. That's this board right here. We're going to talk about native and design flaw failures in these boards. Okay, I'll try to keep this short. And I want to give a shout out to the customer about 6 months ago that sent in his boards so that I was able to get a good read off that PIC microcontroller. So now I have the code. You see my last video on these boards. I did dump the code. I did email it to Tormach, the code and the configuration bits. They have not posted it yet on their GitHub, so I will link it below. Be sure to like and subscribe my videos so I can keep doing this, even though I'm not monetized. But okay, so let's talk about a design flaw failure. And this is the first failure we're going to talk about. I'll try to get all the design flaw failures out. Well, let's just talk about the first one. And any Dave Jones fans will know what flapping in the breeze means. Well, it's a very common problem. This board is mounted on the headstock of a machine that vibrates. Well, if a machine vibrates, you don't want nothing flapping around in the breeze. So you've got the voltage regulator. The voltage regulator sits there and vibrates, and it will break the pins eventually. So you're either with one broken pin or all of them broken, and the part will be in the case, or it'll be hanging by one pin, barely. That is a design flaw failure. Okay, and when those fail, I like to replace them with the LM 340-5s there. The reason for that, I know it's a little bit heavier part, is the LM is a bit heavier built. It has a lot more heat dissipation. So, and the legs, the pins seem a little thicker on it too. But Tormach, how they could have solved this was they could have just put a couple through-hole pads. They could have put a heat sink and bolted that thing down, made it secure on the board. Would have cost them an extra 40 cents. Okay, and they charge what, 140 bucks for this board. Second failure is we get just native failure of the 7805. Means it'll put out 4.5 volts. It'll put out 3 volts. I've had one put out 1.8 volts. Another common failure is that voltage regulator shorts. That means it puts 12 volts to the 5-volt system. And that means any of these parts, your optocoupler, and microcontroller, are all fair game. Another native failure, or it could be a design failure, I have no clue, is Q2. I've seen a lot of Q2s fail. And that's the part where Chipageddon has got us. Both microcontrollers and this, it's an MP-SW45 Darlington transistor. These are out of stock everywhere. Even in China, they're out of stock. So that was a hard one to find. I've got a bag of them now. I was able to find a local surplus seller and get a bunch of those. So I have those in stock now, so there's no more weight on that little transistor. Probably could have replaced it with something else, but I did have a board come in with a failed optocoupler right there. That is a normally closed optocoupler. So to remove that, or to test that, you need to remove your triac. Okay, because that is a normally closed optocoupler. So 1.2 volts, I think the guy, when he was testing it, he put 5 volts to it because he also took out his PIC, because it came up and put 5 volts to that pin, which is not supposed to have it. But, or his PIC could have failed and taken that out. We don't know. But it was one optocoupler. It takes 1.2 volts, I believe it's positive, negative. and then that'll open up. So then, of course, when you have your triac out, do standard triac tests. Okay. Second, or another failure, which I kind of lost count, did Joe Biden there. Okay, is broken trace. So, if you have 12 volts when you activate your drawbar on this pin, right there, you should have 12 volts when you activate your drawbar. Well, if you don't have 12 volts on this pin, look close. You will see this trace is broken right there. Some engineer decided to route out a few thousandths and a few thousandths deep, so put a groove all the way around that trace. So that it looks like either the flux from the factory wasn't cleaned off or something corrosive got in there and it ate that trace away. So to fix that, we're just going to run a wire, real thin wire, about the equal size of that trace, from here, route it through the hole, put a little conformal coating on it, put the connector back on, solder back up, she'll be good as new. Okay. Let me look at my notes. I've done 7 PIC microcontroller replacements due to failed PICs. So that is since I've got the code about 6 months ago. So, I will be doing mail-in repair on these boards now that I've got a cache of parts. They're pretty simple. They have common failures. Like I said, if you don't feel like comfortable soldering, get a hold of me. My turnaround time right now is 1 to 2 weeks. So if you need it quick, order a brand new one from Tormach, send this one in, and have it repaired, and then keep it as a spare. My lead times, depending on parts availability, if I do run out of parts, can vary. But I do have all the common parts that fail on this in stock, ready to go. I think that's it. Be sure to like, subscribe, and I do have a few more videos coming out here shortly. I'll be working on relating to Tormach and the control board for the PCNC 1100 and a few other things, the common failures and common fixes. Have a good night.